Today, we're looking at how AI has evolved, and we're going to examine its expectations and predictions and how those have changed over the years. And in addition to our regulars who are here on the panel, this is a great day to get your thoughts in via Mercana Q&A interface. So you can access that via the QR code, which comes up when I push this button. So if you have thoughts about this topic, use the QR code, throw them in there, and we're going to go through and kind of just generally get an idea of the state of the art. We have people here on the panel that use this kind of stuff a lot. And so I'm going to start with Alex because Alex talks about this a good little bit, and I think this is something
I'm going to throw it to Courtney because I'm still prepping something. So yeah.
Oh, you're still prepping. Okay, great. Courtney, dive in, sir.
Okay, the history of AI. It's curious. It can be traced back to machine learning and the generation, the pre-computer era. Alan Turing is many times cited as kind of the father of AI in his work for the deciphering the Enigma machine in World War II, where he created a machine, a calculating machine, mechanical machine that could solve for this Enigma machine, which was a device used by the Germans to encode, encode messages, encrypt messages so that they could be sent over open wirelesses and decoded in the field. And it was a fairly complex machine that used a bunch of rotating tumblers that varied the key that was used to decode on a continual basis. And it was very tough to crack it if you're just looking at the encoded, encrypted message to back out what was done to the incoming message to create that encrypted message. And he developed a mechanical means which used actually rotating, basically switches, a whole series of rotating switches to calculate all the permutations of each particular letter in that encrypted message. And so that's, of course, where we get the Turing test. And he hypothesized that in the future, we could, if you could build these machines fast enough, they could think like a human could and could, generate an answer that eventually would become indeterminate from whether that answer came from a human or from an artificial intelligence. So that's kind of where I think the birth of AI could be traced back to. Now, this is back during a time when, like I say, logic was done with relays. Later, we graduated to tubes, which is much faster means of switching to replace the relays with. And tube-type computers like the UNIVAC were used throughout the wars to calculate trajectory of munitions, guns that are firing from far away, to calculate where those shells were going to land. They used computers that would do the high-speed calculations to adjust the gun so that they could follow their targets. So that's another source of AI. And then when we discovered the transistor, that indeed made another paradigm shift in the capability of computers, or these computing machines that use logic to determine an answer based on their input and a variety of sensors in real time to determine and calculate an answer based on a variety of inputs. So they had variable inputs, and then they developed all these ran on Boolean logic, which was a decision tree based on Boolean math, which is binary math, which worked well with computers. This Boolean has truth tables like if A and B are true, then C is true, or that's the AND gate. And if A is true or B is true, then C is true. That's an OR gate. So this type of logic is what all computers are built on. And this developed into kind of a machine intelligence, although it wasn't what we have today as machine intelligence. And I think probably somewhere in the last 5 or 6 years, they started moving toward these large language models and a mathematical method of determining an answer and trying to replicate how neurons work in the brain. And only recently have computers got fast enough, memory's gotten fast enough and large enough and cheap enough to be able to take all of this information together and do a analysis of it, predictive analysis, break it down into little parts, to develop how large language models work to generate an answer, however intelligent it may seem.
So if you haven't, by the way, since he mentioned Alan Turing, I'm just going to mention The Imitation Game, which was a fabulous movie about Alan's life story and something that I knew almost nothing about. And I came away from that having immense respect for his contributions to the world. Craig McFarlane.
Yeah, the way I like to think of things with AI, so AI itself is a really big tent. And up until fairly recently, the struggle was, how do we represent the knowledge that we want to use it for? And a lot of it was, we need to semantically understand, describe, and define things in rules. And it was a very meticulous approach. And it's funny, last week, when we were doing the brainstorming, I remembered that my very first job was I worked at a company called BBN, which did a lot of DARPA research projects. And my very first job was training these AI tools they were building on troubleshooting techniques for troubleshooting this power supply and whatnot. And it was interacting with it. And what they're trying to do is, how do we train it on things? How do we encode it? And more recently, as Courtney said, computers have got fast enough so that they can scan lots of data and then use statistical analysis to predict what's the right next thing that corresponds to this, much like you do with spell checkers, where they know how to extend words and other types of things. But with the statistical analysis, it can suck in vast amounts of data and then based on adversarial networks and other types of techniques, come up with, here's the right thing for what's next.
Fascinating. Alex, you ready?
So I thought it would be perfect to ask AI about the history of AI. So and I've been cross-checking most of these. So what I did, I just felt like, we're in a conversation about it. Let's see what it says. And so I said, you are an AI historian. What are the key milestones on AI development? Include even how we imagined it would be. And so some of the things that ChatGPT came up with related to this was ancient myths. And a lot of these, I was searching them. I won't mention the ones that I haven't searched against yet. But it, and all of them seem to be accurate. But Talos is the Greek automated being that would go around the city. So they had thought about those things. The digesting duck I hadn't heard of, from Jacques Vanasson. That he would build things that were replicating things in the real world, and this is in the 18th century. Alan Turing, of course. Then you have the logic theorists. Considered their first AI program. The Dartmouth conference is where, in 1956, is when they say, even on other things other than ChatGPT, that they coined the idea of what they started calling artificial intelligence. Lisp was created to, really to, complete a Turing project. And then you have the perceptron, which started to look at things, and this is in the 50s. So a lot of these things, Deep Blue, of course, in 1997, and Watson in 2011, both of these playing games against players. And so when we think about this all of suddenly coming up, it's far from sudden. It is a, like this stuff has been, really starting to pick up speed in the 50s, and obviously got, with AlphaGo, with DeepMind's AlphaGo, GPT-3, and then as we start to move forward. But this has been happening for I think that's why it was important for us to talk about a little bit here, is that there's this perception that suddenly AI just came out of nowhere. And it has really been something that we imagined thousands of years ago, and we've been building for hundreds of years. And really, it's just been slowly arcing up in how we pay attention to it. But the idea that machines could do things for us, and of course, the entire industrial revolution, was around having machines do things that humans were doing. And I think that one thing we want to think about contextually is, people, talk about disruption of AI. And we just want to be clear that when they're talking about that, they're talking about the disruption of white collar jobs, which is somehow a much bigger deal than the disruption of blue collar jobs. Automation, machines, robots, all of those have been disrupting blue collar jobs for 200 years or more. The Luddites started throwing a tantrum about this a long time ago, and it's been constant disruption. Whereas, this is the first time we've had things that are starting to go to do something different. Now, one of the things that we want to think about as we distinguish this, because I worked in an A-Life company in the 90s, and so I actually had to do a little research on what's the difference between A-Life and today's AI. And really, it was that A-Life was really a evolution process. I'm going to give you something and have you go through lots and lots of evolutions and have you start to build concepts around basic rules. And so it was a much more limited process. If any of you have heard of those A-Life things. And back then, we found it to be very terrifying, like watching what something could learn how to do. And if you look at, we're not going to watch it today, but I would highly recommend looking at adversarial models done by 2-minute papers. If you really want to see what happens when a computer with a simple set of rules, what happens when you just let it go for millions and millions and millions of generations, it will figure out what they have is they have two characters that are trying to protect themselves and two characters trying to get to them. And they have a simple set of rules and they just let them go. And they found that first they would come up with all kinds of interesting things. Then they would start finding bugs. Like they would find out that if they did something random, that they did something random, and then what started as a random bug became the pattern of how they did what they did. It's a very fascinating thing to look at from an evolution perspective. But I think that we want to look at this as this kind of movement towards something, as opposed to anything that's happened over the last 3 or 4 years. It's just now starting to kind of reach some level of maturity.
Jesse Kester.
Courtney, you touched on the Turing test, and I want to jump into that at a little bit deeper level, because I believe that kind of strikes at the heart of what the human experience of AI is and what we consider when we're talking about it as a species. And if you understand a broader context of how he came by this test, it really strikes at the heart of humanity more than it does AI. So the Turing test is a blind test where if there's a gate between you and a person answering questions, and you can't tell if the creature answering questions is a person or an AI, then the AI has won the Turing test. If you can tell that it's a person or a computer, then you have won the Turing test. And the context that I think is really essential to understand this test is that Alan Turing was a gay man during World War II, and he was also an incredibly brilliant man. And the test is really if it's a homosexual or a heterosexual on the other side of that curtain, and you can't tell the difference, why does this matter at any level? So that's where it strikes at the heart of humanity, and that's why I think it's really worth diving into the Turing test at a deeper level. And I imagine we'll come back to it throughout the hour.
Courtney Gooden.
Yeah, I showed this before on a previous program, but the concept of artificial intelligence using computers goes back quite a ways. In fact, I found this going through my shelf the other day. This is a copy of Interface Age, and one of the title stories right there at the top is artificial intelligence and then robot vocal interfaces. Now, this, if you can see the date, I don't know if you can see the date on there, but it's April of 1979. So it was an article on artificial intelligence in this magazine from 1979, when this is before the IBM PC and before the Macintosh, but the only microcomputers had just been introduced a couple of years prior to that, with the Apples, the Radio Shacks, the Ataris, those type of personal computers, and of course the Altairs and the mini computers of the S100 bus. And this magazine, remember when computer magazines used to be this thick? Doesn't happen anymore. But interesting magazine, and leafing through it, it has program examples of artificial intelligence. And basically, at that point in time, the artificial intelligence, let me put it in air quotes, was a matter of robot interface and basically a collection of limit switches for sensory input, which now we are incorporating into a lot of these humanoid robots that Tesla is producing, so that they have hands that are built like humans rather than grippers. And they have sensory inputs on the ends of the fingers, so they know how hard they're picking something up. And all that is it has to use a great deal of artificial intelligence to know how much pressure to exert to pick something up and not crush it, and put enough force on it to hold it so it doesn't slip out of your hand. But basically, it's the kind of sensory feedback into a feedback loop which determines an outcome, is a form of artificial intelligence. And it can be as simple as a micro switch that senses when something has contacted something, to sensors that actually measure the amount of force that's being exerted on the object, and in a closed loop, servo loop to control the motor that's controlling the force that actuator is exerting on the thing that it's trying to pick up. So the term artificial intelligence has been bandied about, and it has changed radically. But the new LLM type of algorithm that has now become, and people, even these days, once they develop this LLM statistical analysis and breaking words up and language up into small tokens, individual syllables of each word, and then building a statistical analysis of which syllables follow which syllables and which words follow which words, forward-looking a large number of words and backward-looking a large number of words, can generate a statistical outcome that can be interpreted as intelligence. And a lot of the mathematicians that have been working on this more recently with the development of these large language models don't know how it comes up with the solutions that it does come up with. So they attribute it to the way that your brain works to put together words in your brain as you're trying to form a sentence. It draws from your knowledge, from a variety of inputs and a variety of experiences to create a sentence. And sometimes AI can be more astute at creating that language than a lot of humans can.
I'm always interested in the phrase, the past is prologue, and I'm wondering, as I look at the artificial intelligence stuff that's rapidly coming towards us, whether that's going to continue to be true, or whether there are processes that we haven't imagined that this new form of look ahead and see what the future is bringing to us that we don't understand at all. Alex, dive back in. We're discussing today.
This is a question that John Preto posted, but because it is specific to what we're talking about, I thought it'd be useful to throw up here. This is the timeline John put together for another presentation, which I think is great. So here you can see, and again, we talked about things that happened even earlier than that, but you see the Turing test, artificial intelligence coined, industrial robots starting to build up in the 60s, AI winter. We'll talk about AI winters in the future. The Deep Blue in 1997, Sony's Abo in 1998, Roombas, which do have a somewhat of a learning system there. Siri released in IBM Watson in 2011. The Transformers, which was a very important, they've been around for a while, but Transformers released in 2017. DALL-E coming out in 2022. I can't believe it's only been 2022 that DALL-E came out, only 2 years ago. Midjourney, of course, in July of 2022, and then ChatGPT 3 in November 2022, and of course, from there after that, we've constantly seen it. And again, I think that's what's interesting is that there is a lot of the competition is different as well. Competition is driving this in a way that is much different than what we saw in the past. I was listening to something, I think it was MIT, something or other yesterday, and they were talking about the fact that one of the big differences between China's AI revolution and ours is that China's is driven from, the government, is paying for all of it. And ours, what's happening now is that a lot of AI researchers are not trying to get government funding and not trying to get published. They're all taking it to, Sand Hill and trying to raise money against it. And it's not just because they're trying to get wealthy. It's because there's more money available. There's more money available in venture to them to do what they want to do, and more of an opportunity to grow it than there is if they publish papers and try to get the government to fund it or try to get academic. And so it's the nature of AI has changed dramatically because the nature of where people are looking for funding has changed dramatically over the last 2 or 3 years.
Jesse, you wanted to get back in?
I love that graphic. I hope it ends up on the Discord, and it reminded me of the most haunting phrase that echoes in my head all day, every day. Slow at first, then all at once.
Yeah.
That does feel a little bit like my knowledge lack when it comes to AI. Let's move into our questions. First question.
Guy Medor in Dacula asks, across the history of the research and development of machine learning and artificial intelligence, when was the problem of explainability recognized, and what strategies have been put forward for solving this important problem?
Jesse.
There's two sides to the explainability coin. I imagine there's infinite sides on the quantum explainability coin, but in the one we're discussing, there's just two. So the first one that we need to discuss is, can you explain this to other people? And the other side of the coin that's really important to understand is, can you explain this to yourself? And we've gotten to the point where the answer is simply no on both sides of the coin. These machine learning algorithms are instructed to adapt themselves to, kind of live their best life independently of instructions from humans, which means the coding it exceeds human knowledge. There's nobody who can go through the code and understand it on a weekend read or anything like that. The best avenue I've found to understanding what these algorithms are doing is something I call reverse diffusion, where you give the same prompt to Midjourney 50 times and see what it spits back and see what it spits back and see what it spits back over many instances. And this will help you understand how Midjourney sees the world. This doesn't give me any understanding of how the algorithm works, but it does give me an understanding of kind of how the algorithm, what its worldview is. And you'll get a better view of that the more you fail to iterate on your instructions to the software than if you do iterate a lot.
I want a T-shirt that says, the algorithm has a worldview. Courtney Gooden.
I'm not sure what they mean by explainability here. My interpretation was, that AI researchers have basically this black box, which is the algorithm that generates, that especially from a large language model, and stable diffusion, which is a generative AI for images, kind of work in different ways. But let's just look at the large language model that comes up with answers by kind of like an autocomplete version. After you give it a prompt, it takes those words and it looks at the statistics of how those syllables and those words in the prompt you gave it compare to all of the language that is in the model that it was trained on, which could be billions of individual tokens that they've scraped off of all the knowledge that it found on the internet. And how it arrives at an answer is kind of unexplainable because a lot of computer scientists who delve in AI can't really. It's non-deterministic. Your response can be a hallucination, and they're trying to minimize the amount of hallucinations there are. And a hallucination is when the AI generates an answer that may not be correct, or it associates one topic with another topic, and it draws a conclusion based on those topics statistically, but not intelligently. So the amount of intelligence and the explainability as to how it's going to determine its answer is a bit of an unknown right now, and we're not sure. That's why you can enter the same question into an AI and get 5 different answers in 5 different AIs and 5 different answers every time you ask that question, because there's a degree of randomness that is inserted in the algorithm it's basically like the creativity dial, and many AI models have the ability to say more precise, less precise, more creative, let you to set certain parameters, which dials in the amount of variability in the mathematical analysis of the data. So it can produce wildly creative, which means not necessarily truthful, but hey, if you're trying to have it write a novel, truth doesn't matter. If you're trying to do a research project on history, truth does matter. So you can vary the amount of variability in the algorithmic answer, but they still can't predict whether it's going to hallucinate and why it hallucinates. They really don't have a handle on it.
My second T-shirt out of this is now going to be vary the amount of variability. Jesse.
In this context, explainability refers to the algorithm creator's ability to understand and explain the algorithm. So you were bang on with your guess.
Alex.
And the problem is most of the researchers don't know. They don't know how it's coming up with what it's doing. But when we really think about it, while people will say that they know, they don't really know how people come up with those ideas either. so I think that the key is really creating the guardrails. It's not so much explaining how it's coming up with that thought process, because it's going to be very hard to figure that out. But it's also very hard to figure out what's in somebody's head when they're in front of a TV, when they're talking to you, when they're, there's a whole bunch of underlying things that are making the decisions for them. Some of it's conscious, some of it's unconscious. So when we think about this, it's not as dangerous as it sounds until you start giving it things that are really dangerous to work on. So that's the challenge, is really when you start to, the stuff we did with A Life, even this was 30 years ago, there were things where we realized, well, it could make a decision that was radically different than what we had expected. Because what would happen is we call it hallucinations now, but what we found was the A Life system would do something where it suddenly it would be doing something, and then suddenly radically find a different way of doing it that was more effective for what it did, but highly dangerous. So if it was given like the tools, the real tools of what we gave it in computer graphics, and so I think that was always the thing is it making big decisions, because the problem is that it's kind of the way AI looks. It feels like it's looking at everything, but it's also kind of looking through a periscope where it doesn't have a lot of actual life experience. And so it can make a lot of decisions that are radically different than, disconnect from reality, because it doesn't have that data yet. And it doesn't have life experience. I think we underestimate the power of life experience, and that there are, a cause and effect. And I think that it's going to be really interesting to see, but I don't think they're going to be able to explain exactly how it's doing what it's doing. They're not going to drive that all the way home. And I think that that's something we have to keep on tracking.
Lots of artificial intelligence, maybe not much emotional intelligence, as they've coined lately. Jesse, additional thoughts?
Alex, I would argue that at this point it is impossible to explain in its most basic sense, to print out the code, read the code, and explain to somebody else what it's saying and doing. So like at the most core essential level of explainability, I think we departed from that late 90s at the latest.
We're still arguing about why humans do what they do too. I mean, we have to understand that this is that we're just as much a black box as anyone else, and that's why we put checks and balances into that. Like I made that list that I just talked about from AI, but I was busily going through all of those, searching them on Wikipedia and searching them on other things. And this is what's important is to create whatever those checks and balances are, to make that happen. Because the one thing that is certain is that eventually these AI tools are going to be able to respond very, very fast, at a level that, that would be very hard for a human to do. And we have to make sure that we understand where we can pull plugs or pins to protect it could be making a film, but it could also be like, there's stuff that comes out of Midjourney that I just go, I don't have any idea what happened there. Like it'll be like normal. And then here's one that's just completely different than everything else, and usually slightly scary.
Craig McFarlane.
So similar to how we don't know about how the brain works, there's a recent study or analysis done. I forgot which LLM they used, but essentially they're doing like an fMRI equivalent where they analyzed everything that was in memory. They gave it a number of different prompts, and they started mapping out what areas were affected by what prompts, and they imaged out quite a bit to find where different regions were dealing with different topics and analysis. So it's kind of the reverse explanation.
It's interesting. I used to hear about tons about prompt engineering, but I don't hear about it as much anymore. I'm wondering if it's just changed the nature of how people create these prompts. And
I think it's prompt engineering is still very important. I think that a lot of us believe that prompt engineering will be less and less important as the system gets better at understanding what we're asking for. But I will say that it's still important. We're going to talk about, all this summer when we're talking about this, we're going to be talking about prompt engineering at some degree. Of that, if I gave when in the AI thing that I talked about earlier, I gave it a reference point. This is what you are. Like if I had said you're a school teacher, it would have given me an entirely different answer. Like the mistake when people see hallucinations, one of the first things they do is you want to define the starting point for the solution. Then you want to define what you're trying to solve, and then you define how you want to solve it. And that's one technique. There's many techniques to do that. But the point is that without that, it can go all over the place, and it's the same thing with human beings, by the way. But you go to that human being assuming that they know a certain thing. So, but being able to do those things. So I think there's a certain understanding. Same thing with Midjourney or other things, knowing how to ask for something, and that's the same in life. Knowing how to ask for something gets a different result, and so I think that it's just knowing how to ask for things, but it's also dancing with the system getting smarter and being more likely to give you what you're asking for as you go forward.
Next question.
Ronny Hofsø in Tromsø, Norway asks, when was machine learning replaced with AI? Is many services marketed as AI really just machine learning?
Craig McFarland, start us out here.
Yeah, so I think a lot of this was answered in the previous question or topic. But if you think about AI as a whole, large tent, within that, there's machine learning. And so a lot of the recent advances have been in the machine learning, building up that knowledge base very quickly by doing powerful analysis and statistical modeling of that data. So it's all within AI, so it's not necessarily replaced.
Courtney Gooden.
Yeah, I think a lot of marketing has dubbed machine learning to be AI because it has a buzzword. It's a buzzword these days. It can be used to market products, just like, when digital came around, everything was, the new digital hairdryer. It didn't necessarily have anything to do with it. AI can be considered, for example, an idea of machine learning that's involved in your everyday appliances, like your Roomba vacuum cleaner uses machine learning to map out your living room. And once it learns by taking inputs from different sensors and adjusting its programming based on the inputs from those sensors. So it determines then where the size of the room is and where the couch is and where the stairs are that you don't want to go falling down, so that it develops a room map, which it stores in memory. And so that uses basically machine learning to map your living room. This has been used for many years. I've written code back in the 80s that was self-modifying code, which is always dangerous, that a computer program that would change its program and its algorithm based on the response from the people that it's interacting with or sensors in the real world. It would lock out certain portions of the code and it would never come back to it based on what its sensor input was, or would actually change the code itself to do something different based on the response that it gets from input from other forms of input from the computer. So that's a form of machine learning. And eventually the AI that we interpret today, like large language model-based statistical analysis of words, is quite a bit different. It's similar in the fact that it's learning by training itself on a large corpus of data and generating answers based on statistical relationships within that data. So it is kind of artificial intelligence. It's more like artificial intelligence than just machine learning, which is like I described in the Roomba.
Jesse Kester.
Regarding marketing, AI, it can be such a broad term that even a doorbell could be considered artificial intelligence because it is not naturally occurring and it only makes that sound when it understands that the user wants that sound to be made. So please ignore AI in any marketing material you see from now till the end of time.
Next question.
Roscoe Jones in Madison, Indiana asks, the Logic Theorist was an early program designed to mimic the problem-solving skills of a human. What software do you regularly use that mimics human thinking or just seems to understand you?
Alex Lindsay.
I think that we're moving past it trying to mimic how humans think. I think there was an obsession with building up these systems so that they would do it the way the humans do, but we don't even understand how the humans do it. I mean, I think we have a lot of people who say they think that they understand how humans connect things, and they write a bunch of papers for it, but a lot of things fit outside of those sets of rules. And you talk to 5 psychologists, you'll oftentimes find 3 to 5 different theories about how that all works. So I don't think that but I do think that things that start to understand you, to answer that part of the question, I think machine learning is a big piece of that. When my phone, for instance, knows that when I'm at Whole Foods, I'm probably going to pull up Amazon because I got to scan my little in-store code, and it's gotten really good at popping that up. If I go, what apps would I want now, and it's starting in more and more environments. It's starting to figure out you're in this location. You're probably going to want to do this, and so it's making those very basic decisions. But I think that you'll see more and more of those things start to customize.
Courtney Gooden.
Well, we are all faced with tools that we use every day. If you use a phone and you do, if you start to thumb type something on your phone, it will have autocomplete, and it'll choose the most likely word that is next. And then you just hit the tab key. Yeah, that's the word I'm thinking of. Go to the next one. Sometime it'll be wrong. Sometime it'll be right. But it learns. It does learn that if I type a G-O, it'll go Gooden. That's not in the normal database of the next likely word, because it observes what I've been typing, and so it keeps a local response. So it's machine learning, because it's learning what I would type next, not necessarily what everybody would type next. It's most statistically likely that would be the next word. So if I start to type my email address, I can type just the first 2 characters, and it goes, he's probably trying to type his email address, and it puts my email address up there as a choice. Well, my email address is not likely to come up in anybody else's autocomplete. So that's a way that it mimics our the human brain and recognition and what we would type next and how we're deciding to form a sentence. And your phone machine learns from your actions with the phone.
Craig McFarland.
Yeah, so there's a chatbot from Inflection called Pi, P-I, and they have a phone app, and I have used it quite a bit, because one of the things it's both spooky and really exciting is you can talk back and forth to it in a very conversational tone, and it's kind of the opposite of prompt engineering. Is I can have conversations with it and go deep and forget that I'm talking to an AI. So they tuned it very much to human interaction and simulating more of what a real person would say. And I found that interaction surprising. So worth
Alex?
checking out.
Oh, excuse me, Craig.
Yeah, I know with ChatGPT 4.0, I'll do a walk, and I'll walk for an hour and a half, sitting there just asking questions about something. And it's just simply, I'm walking and it's talking to me, and it is a relatively comfortable experience. And I absorb a lot. I still have to go back and cross-check everything, but I would have to do that if I searched on the web. When you search on, I think I was thinking about this over the weekend, is when you search on the web for something, you get one person's opinion. Maybe it's better than others. When you do ChatGPT, oftentimes you get the average of many people's opinions, and sometimes that's better, and sometimes it's worse. So it just depends on. But again, trust but verify all the time. It really is something that we need to think harder and harder about every single day. Is that no single point of information is the truth.
Next question.
Gary T. in Cape Town asks, given the increasing role of AI in various industries, How can individuals safely and effectively learn AI skills, particularly in the context of prompt-based learning versus using prompt generators? What are the potential advantages and limitations?
Jesse Kester's going to start us off here. Jesse?
Play, frolic, make your ChatGPT account, jump on Midjourney, and just play until you get that feeling of what it does well, what it does poorly, what it absolutely cannot do at all to save its life. Frolic, enjoy it.
Hopefully, how you learn as a human in the early days. Alex?
Yeah, we've talked about this in the past. The way to learn is to watch, ask questions, do, ask questions, repeat. And that's how we generally, that's the methodology that most humans have used for the last million years. I follow a lot of people that are constantly delving into AI. I also play with it a lot. So I'm one of the big things I do in Midjourney is I do most of my prompting now from their webpage and less from Discord. And when I do that, I find that there's a huge gallery, and I look at the gallery and I look at what their prompts. I find images that I like, and I go, what did they say there to get that? And oftentimes I'll try to do the same thing that they did, or something similar. I'll change a couple things and move it around and see how it changes. But those are the kind of things that that's how I learn from other people of how to prompt things. I do, again, pay a lot of attention to. I follow a lot of people on X that are in an AI. And so that I can kind of constantly see like, oh, we figured this out, and it saves me a lot of time of fiddling around. So there's so much information floating around right now about this, but we are going to spend at least the next 8 weeks talking about this so that we can start to hopefully get your feet kind of at least on the playing field, for you to play with it.
Craig McFarland.
Yeah, not to echo everyone else, but I think not just play yourself, but do it regularly. Assign a certain amount of time during the day, like before or after lunch, or some period where you can just play for 20 minutes and think about the activities you're doing. And, I've got to do this write-up, or I've got to analyze this report, or do these other things. Thinking about those specific little tasks, and try. The smaller the activity or task at hand, the easier it is to play with. But I'd say make sure you do it every day, no matter how short it is.
Next question.
Ryan Rademan in Chicago, Illinois asks, we've seen more than one AI winter. Do we feel another is coming in the near future?
Alex Lindsay.
And Ryan posted a couple things here. So this is kind of some of the progression that you can see here of this. Some of these winters where people gave up on it. There's a more detailed one if you search AI wintered here, you had a failure of machine translation, criticism of the perceptrons, which we talked about earlier, DARPA's frustration. So one thing that when you look at these winters, it's mostly like DARPA threw a bunch of money into it, and then the one thing to think about when you see DARPA though is, were they frustrated and stopped funding it, or did the funding just go to a more internal facility as opposed to an external facility? So we're not sure exactly where all that went, that DARPA money. But one thing we do know is that we probably wouldn't be anywhere close to where we are now without a fair amount of government funding from a lot of different countries trying to figure these things out. So DARPA has been probably the largest funder of AI in the last 30, 40, maybe 50 years. So of figuring out a lot of these of how these things can actually work. But I don't think that we're going to have the same AI winter that we've had in the past, because before it was largely a handful of industries or a handful of researchers. It's now everyone. Like everybody's using it to some degree. I don't know if it's everyone, but it's a huge. I was listening to an article yesterday said that in business now, it's 35% of the workers say that they're using AI at some point during the day. So it's really has changed. It's become something that's a kind of a fabric of what we're all doing, or what 30% of us are doing. And so I think that that's going to make it much less likely that we're going to see we may see a drop off. I mean, I think one of the the dangers is really that is being able to distinguish AI content on the web from non-AI content. And the reason that that's important is because the AI is using the web to learn. If it starts learning from itself, it will start to lose its center, because it doesn't have any life experience. It's now talking to itself related to that, which is, talking to yourself is usually a first sign of insanity. So the real challenge is being able to distinguish that content that's out there and what's being generated by AI and what's being generated by humans. And I think that that's where, it's going to be really interesting to see how Apple does what it does, which is this kind of private cloud, because my guess is what's on your device and what's on their private cloud will be heavily vetted as human content, whereas they probably continue to allow you to go out to something that might hallucinate, but it's kind of protecting their future from this potential issue that I think people are working on, but it's still an issue.
Jesse Kester.
I might have to leave panel if get this checked out, because I talk to myself all the time, and I'm hoping it's not a revealer of insanity.
Do you answer yourself
out loud in public? It's talking to yourself out loud in public. Yeah, exactly. And we can talk to ourselves all the time. Otherwise, all three of us can converse.
That's right. My evil Bill, my good Bill. Yeah. Craig McFarland.
I did have something I wanted to
go ahead, Jesse. Sorry about that.
We've seen a lot of, particularly in the last year, we've seen a lot of weather with AI. What will reveal itself moving forward is the actual climate. So we see these, we see a tornado, then we see a hurricane, what we're going to see from now moving forward is what the actual climate of AI is and how humans actually interact with it on a day-to-day basis. So we will see ebbs and flows, but it'll be a lot more useful for understanding our relationship moving forward.
Well, it'd be nice, particularly if we don't like the climate we're in, if we can change locations and find a new climate. That would be cool. Craig McFarland.
Yeah, so just the term, AI winter, it's a rear view mirror. It's looking back. And so people didn't know, we're about to enter a winter. It's more after we're in the trough of, hey, our expectations not being realized and whatnot, that they finally say, oh, you know what? I think we're in a winter. So that said, we've had so many gains over the past few years. The speed may not be, we may not be accelerating as much as we have over the past couple of years, but I don't think it's going to reverse from where we are now.
Courtney Gooden.
Well, I think it's where, the hype precedes something, and then the reality, you start using it. And if the reality doesn't live up to the hype, then you become disappointed, and that can create a rejection of that because it didn't meet with the advertising hype that it was supposed to. There's also the fact that you kind of hit a brick wall through technology. You can come up with a new concept of, like machine learning or AI. It can go up to a certain point. It becomes ubiquitous. Everybody uses it. And then it becomes passé because, hey, everybody's using it. It's not unique anymore. So we're looking for the next big thing. And until there's a paradigm shift in computing power or memory storage or something that will allow us to move beyond that kind of brick wall that we hit that determines the usability of the current level of technology, will we, create another summer of AI to get past those limitations? Once it becomes passé, everybody's using it, the hype wears off, the thrill wears off. Look at 3D imaging and spatial computing. We've gone through 3D movies, have gone through about 4 or 5 popularity cycles and then winters, and people go, oh yeah, another 3D. I don't want to do that. I don't want to pay extra for that, et cetera, et cetera. And then the same is true with almost any popular thing in society. It becomes passé. People are bored with CGI in films now that they can perfectly reproduce something that looks absolutely real on film. It's become, another bunch of pixels dancing around. I don't need to see that. Give me a good story. It loses its shininess.
Next question.
Roscoe Jones in Madison, Indiana asks, does a machine need to store results internally to be considered intelligent, or can the results and programs depend on their human keepers for storage? Early computational machines had no storage.
Alex Lindsay.
I don't think that that's a decision process of intelligence, but I do think that they're usually working off of some model. So that model's in storage somewhere. It may not be in the computer that's actually doing the calculation, though.
Courtney Gooden.
Well, it has to do with efficiency. You don't want to have to enter the same prompt over and over and over again to get the result. It should learn from what you've asked previously. And usually that's stored locally, which is most of the chatbots let you develop a thread, and it knows what you've asked previously, so you don't have to restate the entire question. You can say, well, what if Tom was a woman, or what if the sky was green, and it can know what you're talking about based on what's stored locally in your computer or locally in that session as to that thread of AI intelligence. And so it's a lot more productive if it builds on what you've interacted with it in the past and remembers that. So it prevents it from being repetitive and you having to, it's much more efficient than others.
Next question.
Guy Medor in Duckula, Georgia. Humans create tools to solve problems. AI technology, including LLMs, are tools. The more complex the tool, the more carefully we need to be to set explicit expectations, requirements, and limits on the tool's use. Please reflect on this.
Craig McFarland's got to start us off. Craig?
Yeah, so I think a lot of it, I think of it similar to when the calculator was introduced. It was this big deal, and people started relying on it without even thinking. So doing long division, they didn't do it by hand anymore. And the teachers, good teachers, were really hard on people to understand. You understand what it's doing. You can use it for efficiency, but you need to understand to be able to tell if it's correct or not. And so using AI tools, if it's producing something, here's a better language, you need to understand, well, is it hallucinating? Is it not? And so you still need to know the subject matter, the context, and all of that. And also, if you start with a smaller, more granular type of situation or problem, you're more likely to be able to see the result of it, and it won't have such wide impact.
Jesse Kester.
Yeah, we have to put limitations on this. And going back to the problem of explainability, if it can't be explained by individuals, I don't really understand how it can be explained to individuals, particularly people who legislate. And so for all of my enthusiasm for these tool sets, if you yourself feel kind of nervous or anxiety about the effects they're having on your life or will have on your life, please do express them to your elected leaders and try to move the needle towards more understanding in our regulation bodies and better regulations.
Courtney Gooden.
Well, like all tools, there's responsible use and there's irresponsible use. You can use a hammer to build a house, or you can use it as a serial murderer to kill people with. But should you put restrictions on hammer sales so that because someone has used serial killer, has chosen a hammer as his means of perpetrating his serial murders, should we limit the use of tools based on the illicit use of those tools? And this is a big problem for AI because they can greatly improve our lives through their proper use and responsible use. But how do you prevent irresponsible use? And they're trying to put guardrails now on AI because they're so powerful, and the general public may not have been exposed to what is generated by AI and what's reality, and to be able to tell the difference between the two. So they put up these guardrails, but these guardrails, of course, make using that tool much more difficult. If you had to put foam padding around a hammer and then try and use it to build a house, it's just not going to work for you. So I look at the same way as guardrails around AI use is you have to determine how to limit their use, that these powerful tools, how to limit their use to those that are responsible and know how to use them and won't use them for evil. And that's a very difficult test to do through any type of legislation or regulation.
Next question.
Next one is for me. Can you think of early examples of science fiction dealing with the concept of AI? I recall the 1960s episode of Star Trek where Landru, a computer programmed by its creator, was used to run an entire blissfully unaware society.
Alex Lindsay.
And we had Lost in Space, so that we had the big robot in Lost in Space that was there. Data in the 90s was an exploration of that idea. So I think that those are, I think that those are some other examples.
Courtney Gooden.
Well, of course, there's the classic "Open the pod bay doors, Hal."
Exactly.
Arthur C.
How did we miss
Clarke
that one?
in
Yeah, exactly.
2001, written in 1968, I might add, and how artificial intelligence can go awry. So that's the perfect example of machine intelligence and how you have to be careful when you hand over all of the tools to run things to a machine intelligence. Sometimes it can develop a personality of its own. I can't do that, Dave.
Jesse Kester.
3,000 years ago, the Iliad shows Homer describing the god of fire forging women of gold to do his bidding. And I can't find a reference to AI older than that one. There
you go. Alex?
Yeah, I think that we've been definitely thinking about it for a long time. I think that Blade Runner, of course, I don't think we've mentioned Blade Runner before, but that's but another example. I think most of our things, iRobot, many of those things, I think we have worried about this for a long time. People say, well, people aren't worrying. I'm like, almost every time we talk about AI, we talk about how dangerous it could possibly be. So it'll be interesting to see what happens.
Next question.
Guy Medor in Dakila, Georgia asks, how does the Chinese room problem inform your understanding of past, current, and future AI technology?
Jesse Kester, have you delved into the Chinese room?
The Chinese room problem is not entirely different from the Turing test. It supposes that somebody who doesn't understand Chinese is locked in a room with no other stimulus, but every day a note slides under the door with only Chinese written on it. And by studying these, the person who's in the room eventually figures out the correct responses to the characters that he's being sent, even though he doesn't understand what any of the characters mean or how to read it or how to speak Chinese. He can deliver the correct characters back under the door to convince the person on the other side that he understands Chinese. This is essentially the Turing test. And kind of there's something like the Turing test is really fun for people to talk about of can the computer trick you? But what I want to remind everybody of is that there are more ways to complete the Turing test than for the computer to trick you. So the basis of this test is can the judge distinguish between the computer and the human? This can be achieved by the computer emulating the human perfectly, but it can also be achieved by the human emulating the computer perfectly. And the real troubling part of the Turing test is the test can be achieved by the judge being unqualified to distinguish between a computer and a human being. And this is kind of at the core of my concerns as a human being moving into the age of common artificial intelligence is, do we, the judges, have the information and the wisdom that we need to distinguish between a computer and a human when we're engaging with a curtained experience like Facebook or YouTube, where we don't really know what might be on the other side of that content generating device.
Well said. Next question.
Douglas Carmichael asks, one barrier to making genAI a true companion for daily life are the rate limits imposed by the current platform operators. I've run into this with Claude myself. Do you think that this will become less of an issue over time?
Alex Lindsay, what do you think?
It probably will, and you'll also find that more and more of it's on device. So you're going to see, as we take more advantage of this, more of that's going to be on device, which will be much less contained. But right now, it's a lot of energy that is required to make this actually happen. That's why it costs money and why they're putting limits on it.
Courtney.
Yeah, exactly. As Alex said, it costs a lot of money to run these models, and most of these AI providers are running at a loss right now. And so if you're trying to monetize this, you're going to have to move it onto your local machine. And as quickly accessible memory decreases in price, and the availability to address that memory quickly on your local machine is such that these AI models can be moved and condensed down and moved to your local machine, then the price will get cheaper and you won't have any limits on it, on interacting with it, because you're paying the electric bill instead of the AI provider.
Let's see, Jesse.
Pay for it. The biggest, the most corrosive lie we were fed about the internet was that it should be free to you, the user. You should be able to jump on Facebook, YouTube, Twitter, and have the full experience without contributing financially to it. And please examine the current state of Facebook to understand why I encourage everybody to pay for their online experiences instead of accepting the free version.
Next question.
Douglas Carmichael asks, Anthropic has extended into government market, including potential use for providing warning in advance of potential military activities, opening a window for diplomacy to prevent or deter them. Will we get to a point where AI can do that?
Alex.
Yeah, I mean, they're already talking about models where they show all of these lung scans, for instance, to AI. And AI will show you, like, hey, in 6 months, this person's going to have cancer. AI doesn't know why, and neither do the doctors, but it's accurate. So these models are, like it's seeing some kind of pattern there that they can't quite put their finger on. So it being able to look at a variety of things and being able to kind of give it back to you, it doesn't mean that you should start making decisions based on it, but it does mean that it gives you a bunch of information, like, hey, I'm looking at a lot of information all at one time, and this is what's popping up. And so I think that's going to be interesting as we go forward.
Courtney?
Yeah, the military has been using AI for decades now in determining a probability of reactions in specific war game scenarios. Can we play a game? The movie War Games was based on computer simulation of military response. You face it every day, and you have to make decisions. There's kind of AI built into your smoke alarm. Is that smoke I'm sensing burning toast, or is the house burning down? And as it gets smarter, it will be able to determine the difference between those two and not give you false positives. So there's the local way of interpreting that as well.
Jesse?
To me, this is what's most exciting about AI is predictive models that can understand things that humans simply don't have the capacity to understand. And this can be very revealing in medical. This can be very revealing in weather patterns and climate patterns. I'm hoping we make some advancements in earthquake prediction. I think we get like 2 minutes maximum warning before an earthquake with our current technology. And the possibility of an AI model understanding things that are invisible to us and translating that to even a 10-minute warning would save, millions of lives over time.
I've been so excited for this week, and it has been meeting my expectations and then some. Thank you to everybody for participating. We're going to be doing this general topic for a while here through the summer. So thank you to everyone who's contributing, first and foremost, to the panelists who come here and discuss this and bring their wisdom to the show every day. I'm just constantly impressed by the number of people who can weigh in on these topics and do it intelligently and with meaning. To our producers, the people who ask the questions, this show is run based on what you ask every day, and you always surprise us in the most positive fashion with all of your well-considered questions. So thank you very, very much for that. And eternally, the back-end crew people who are quietly sitting all around the world, enabling office hours on the technical side, on the setting up side, on the getting all the computers running. This really does have a huge village behind office hours, and we appreciate the input of everybody, whether they're online in real time now with us or whether they're working behind the scenes to set up things for the future, to book guests and do all the rest of the things we do. We really appreciate what you're doing. Our stats for today in the Talak Traversal, we've traveled 58,000 miles. That is 90,000 kilometers. And most importantly, 443 million bananas for scale. We'll see you tomorrow.
Banana calculated by AI.
Courtney has been taken over by nanobots. We'll see if we can clear out his system for tomorrow.
See you, everybody.
The number of movies or TV shows that have had AI on it, we could go on all day.
It seems like that's a second hour on its own. AI in movies somewhere in the future.
Colossus, the Forbin Project.
Yeah, that's a good one.
Yeah, that'd be good. That'd be good.
All right. Take care, all. Great stuff.
Good to see you, Craig. Thank you.
Yep.